In this video, we're going to walk through the process of solving one of these review exercises from Chapter 4 dealing with linear regression. So first of all, notice that we're given data in this table here. I'm choosing to put this data in my calculator because the data, well, there's not a lot of data. So to do this process, I'll go to Stat, press Enter for Edit, and this gets me to the list. In the list, I'm going to type in those X values and the Y values. To move over to the other list, I can do like this with the arrow key and press in the next value and press Enter. So I'm going to go ahead and put in that data in my list. Now that the data are in my list, I want to find a scatter diagram. So that's the first part that we're being asked for here. And to do this on the calculator, I'm going to use stat plot. So to get to stat plot, I press second y equals. I'll press enter to enter plot 1. I'll press enter to turn it on. And usually by default, it's already on the scatter diagram. List 1 is the X list, list 2 is the Y list. So if you stay consistent there, you don't have to change a lot of these settings. And from there, if you press graph, you probably won't see the points on the graph. These are some larger numbers than our standard window. So a shortcut is to come to Zoom and select number 9 for the statistics window. So I'm going to do number 9, and now I have a good scatter diagram that I can compare to my answer choices. Just also watch the scales that you see here on the X and Y axis for your choices. This is the better match. So next we're asked to find the equation of a line containing just 2 of these points. Now only 2 of these points, so that's going to be important here. We can go back to by hand methods, or we can continue to use the calculator, but we need to make sure that we're only using these 2 points. I'm going to continue to use the calculator. So I'm going to come here back to Stat and Edit. I really don't want to erase all the data I've already typed here, but I'm only going to type in these 2 points, their X values and their Y values, in list 3 and list 4. So I'm going to need to make sure I'm referring to list 3 and list 4 when I calculate the equation of this line. So I come back to Stat, scroll over to Calc, that Calculate menu, and I want to select number 4, linear regression. Now my X list, my X values are not in list 1. Remember, we placed them in list 3. So list 3 is above, in blue, above the 3 key. List 4 contains the Y values. I can go ahead and tell the calculator to put this equation somewhere. This is a good practice to do. So the shortcut key to say put this in Y1 is alpha trace and enter. And then scroll down to calculate and press enter. And now I have those A and B values that I need for the coefficient of X and the constant. As always, pay close attention to what you see in the instructions below where you're typing in these values. These tell us to round to 2 decimal places. So I did that for those values. Next, we're asked to choose the correct graph of that line on the scatter diagram. Well, here's where using that Y1 shortcut of alpha trace helps, because when I go to Y equals, that equation is already pasted in there for me. I don't have to retype it. It's not totally, time consuming to retype it, but I would want to retype this one here. I can press graph, and I see that graph on the screen, how it contains the 2 points that were listed. So again, I just want to make sure that I'm matching the best graph. And in this case, this is the choice that's the best graph. So up next, now we're asked to determine the least squares regression line. I do want you to rely on technology as much as possible. So whether it's the calculator or StatCrunch, we're going to use technology where we can, not the long formulas. So let's go back to Stat, Calc. we're also going to select linreg, short for linear regression. This time I want to make sure that I'm referring to the full list of x values and the full list of y values by using L1 and L2. I'm just going to rewrite on top of the y1 I had before. So I'm going to store this equation in y1. Again, that shortcut was alpha trace enter for y1. And then calculate. And this is the least squares regression line for all of the data. So let's type in these values rounded to 2 decimal places. Up next, we're asked to graph the least squares regression line against that scatter plot. So I'll press graph. This is what I should see. Again, just pay close attention to any of the scales. I see that this time they're all the same. And some of my choices look really close. I'm looking at choice A and choice D. So I want to pay close attention to that and make sure I'm picking the best choice. And it looks like A is the better choice here. So after that part, you're asked to compute the sum of the squared residuals for the line found in part B. Now this is important. The line that we found in part B, I'm going to scroll back up, is right here. We're going to actually calculate those residuals, but I don't want to calculate them by hand. I'm going to get a little creative with my calculator by going back to Stat and Edit. The first thing I need to do is calculate what that line says the outputs are going to be. To do this creatively, we're going to scroll to the top of list 5. This is just the next blank list. I could have wrote over list 3 or list 4, but I'm just going to the next blank one. I'm going to type in this equation, starting with negative 3.17, and my x values are stored in list 1. So here in parentheses, let's refer to list 1, and we're going to add 123.17. It works similarly to a spreadsheet, if you think of it that way. We just always have to make sure when we give commands like this that we're at the very top of the list, like L5 was highlighted when I did that there. So I'm going to scroll over now to the top of list 6. To calculate residuals, we take what actually happened in the data and subtract what the line says it should be. So I want to subtract all the values of L2 minus L5. So again, make sure you're at the top of L6 when you do this, or the top of some list when you do this, and we're going to subtract those 2 lists, and here are my residuals. Now I'm asked for the sum of the squared residuals. So remember that these residuals are in list 6. Remembering that, let's go back to Stat, Calc, and we're going to select number 1 var stats. We want to make sure that we're referring to list 6. We'll scroll down and select Calculate, and the sum of the squared values in list 6 is 129 when we round to the nearest integer. This works a little bit differently when we calculate the sum of the squared residuals for the least squared regression line, because we can skip a couple of steps, just a couple of steps here. One thing I need to do is make sure that the last regression that I ran was the least squared regression line. So if you're not sure, because we've had a lot of parts here, it's no big deal to just rerun that regression real quick. Make sure that we're referring to L1 and L2. These are the actual data, all of the data. And the reason I did that is because the calculator stores the residuals in its own list. You see here in blue above Stat, it says List. If I go to Second Stat, I can access all of the lists, and one of them is named Residuals. So I'm going to come back to Stat, Edit, and actually I think I'm going to clear one of these lists because I'm ending up with so many lists here. Let's go to L3, the top of L3. I'm just going to press clear and enter. And now when I go to the top of L3, I want to refer to the residual list. So to access that, at the top of L3, press second stat and select number 7, the residual list, and then enter. So it's a little bit shorter because it actually does calculate the residuals as part of the regression, the linear regression. Now I can quit this, so that's second mode to quit. I'll come back to stat, calc, 1var stats. I'm going to do the statistics for list 3. That's where I stored the residuals for that particular list. And the sum of the squared values, the residuals, is approximately 44 when we round to the nearest integer. In the last part of this problem, we're asked to comment on the fits based on these sum of squared residuals. And we see that the sum of the squared residuals found for the line in part B is greater than the sum of the squared residuals for the least squares regression line. That's because it's called the least squares regression line. It has the smaller squared residuals. And since the sum of the squared residuals provide a measure of variation in the response variable that is not explained by the model, the line found in part D is going to be the best fit.